Today's lesson is on graphing parabolas. Parabolas are the graphs of quadratic equations. Those are equations where the highest exponent is 2. We have 3 forms of quadratics. That's standard form, where you have y equals ax squared plus bx plus c. We have factored form. That's where it's already factored. And we'll review factoring in case you don't remember that from Algebra 1. Also, we have vertex form. And this is the one we'll be focusing on today. By the end of today, you'll be an expert at graphing parabolas. So first of all, let's review how to graph what we call the parent function. This is just a regular parabola with no shifts or anything. So y equals x squared, we're going to start off by making a table of values. So if we plug -3 in, order of operations says that we have to do exponents first, so that's a +9. -2 squared gives us a +4, 1, 0, 1, 4, and 9. We're going to plot these ordered pairs. -3 goes up to 9. That's off the graph, but that's okay. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 2 goes up to 4. -1, 1, 0, 1. Over 1, up 1. I want you to memorize this shape and notice the symmetry. We want to make the bottom nice and round, and then try our best to keep it round. This is our parent function, the standard parabola. I want you to memorize this. From the vertex, we go over 1, up 1, because 1 squared is 1. 2 squared over 2 goes up 4. Over 3, up 9. So forth and so on, and both sides are the same. Now, if we make the parabola negative, let's make a table of values for this one. If we plug in -3 in here for x, that's a -3 squared. So we have to do exponents before we can do this negative sign. So that's a negative, and then -3 squared is positive. So the overall answer is -9. Likewise, this will be -4, -1, 0, positive. And if we plot these points, we'll see the same exact shape but flipped down. -3 goes to -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. -2 goes to -4. And we'll see the same shape, and notice that the vertex is at the origin 0, 0. And again, we want to make sure it's nice and round and never pointy. And the more you draw them, the more practice you'll get. Okay, so we can see the difference between the positive parabola and the negative parabola. Let's take a closer look at vertex form. Vertex form is called that because we can see the vertex. Opposite, so if this is +3, you make this -3. If that's -7, you make this a +7. And whatever this number is, you just keep it the same. The plus sign tells you to open upward. And if it's negative, you open downward. Okay, so you're going to flip it. Don't forget the regular shape. the parent function. So now, let's look here. We can start off by figuring out the vertex. So we're going to go opposite. So that's -3. And keep this one the same. That's -4. That's the vertex. Now we go to the vertex. -3, -4. 1, 2, 3, 4. And now, because this is positive, that means this is going to open upward. So I'm going to do the same shape that we did before without a table. So I'm going to go to this vertex, and I'm going to go over 1, up 1, because 1 squared is 1. Over 2 goes up 4. 3 squared is 9. But notice how I keep returning to the vertex. And do the same thing on the other side. 1 squared is 1. 2 squared is 4. 3 squared is 9. And this is the same exact shape. But instead of going to the origin, I just kept going back to our vertex. Later, we're going to learn about axis of symmetry and talk about some other stuff. But for today, I just want you to become an expert at graphing these. Let's change the color on this one. Now, my vertex, we go opposite. So that's going to be +2 and keep this one the same. So this one is the same. This one is always opposite. So that's going to be a +5. So I'm going over 2 and up 5. Make my vertex. And now this one opens down. The negative sign tells me to open downward. I'm going to make the same shape. 1 squared is 1. 2 squared is 4. 3 squared is 9. And you do the same thing on both sides. 1 squared is 1. 2 squared is 4. 3 squared is 9. And now I make the same shape but open downward. Hopefully you do remember learning about parabolas in algebra. So it's just that easy to graph a parabola. Now, let's do a couple more. Here, there's no number written out here. So we have to be careful to put a 0. So for my vertex, I'm going to go opposite, always opposite of the x. And then since there's nothing there, I'm going to put a 0. So 4, 0 is my vertex. And I'm going to open upward because it's positive. Same shape. 1 squared is 1. 2 squared is 4. 3 squared is 9. And this same thing over and over. We're going to continue this shape. Uh-oh. Don't make it pointy. Nice and round. Okay. So now let's look at the second graph. There's nothing in the parentheses here, so I'm going to make that a 0 and keep the sign the same. 0, -4. 1, 2, 3, 4 is here. Same shape. 1 squared is 1. 2 squared is 4. 3 squared is up 9. And there I have a cute, cute parabola. Alrighty. It's as simple as that. Let's go ahead and see what happens when A has a coefficient other than 1. We're going to make a table for this one. So if I plug in negative 3 n for x, you do exponents first. So that's 18. And if we continue to populate this table, what we're going to notice is that we are doubling the squares. So our shape is going to change, and we're going to have to memorize new numbers. So we're no longer going to say 1 squared is 1, 2 squared is 4. We're going to double those values, and I'll show you how to do that. And I'm going to go ahead and populate that table for you. So if we go back 3, we have to go up 18. That's off the graph. 2 goes up to 8, 6, 8. And what you're going to notice is that this graph is skinnier. This parabola stretches upward. It's more narrow. And make sure it's nice and round and not pointy. And it's positive, so it's still turned up. So let's look at our new points. If we go over 1, 1 squared is 1, but we double the 2. 2 squared is 4, but we double the 4 to 8. Uh-oh, wait a minute. I didn't go up enough, huh? This should have been up there. That's 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Oh, no, I was at the right place in the first place. Okay. So now, let's go on to the worst case scenario. We're going to graph y equals negative 2 times the quantity of x plus 3 squared plus 5. So, my vertex is negative 3, positive 5. Remember, we go opposite, same. So now I'm going to plot that point, negative 3, positive 5. And I'm going to show you the shortcut. Without making a table, we're going to graph this. So I know it's opening downward. So I'm going to say 1 squared is 1, but I'm going to double it to 2. And I'm going to do that on both sides. 2 squared is 4, but double the 4. Double the 4. So 1, 2, 3, 4, 5, 6, 7, 8. And I do that on both sides. How much if I go over 3? How much would I have to go down? Let's see. 3 squared is 9. That doubles to 18. That'd be clean off the graph. So I'm just going to make sure I keep it nice and skinny as not to go over too far.